is a talk on a CNN-LSTM approach to human activity recognition.
It's better for you again.
Good morning, everyone. My name is Alwinpoulosepalatty, a PhD student from Kenbuk National University, Daegu, South Korea. And here is our topic, a CNN-LSTM approach to human activity recognition. And this is my colleague work I'm just presenting, but I'm part of this project, so I think I can explain. So during the presentation, we like to introduce our research, the current research and future research, and we like to introduce some concept related to human activity recognition. And in this research, we proposed a method in the area of HAR, human activity recognition, and we compare with our own data and universal data set, and we made some analysis result, and we improved the accuracy of the system. And finally, we discuss about our result, our experiment scenario result, and finally I conclude my words. So in the introduction, we already know about human activity recognition, how the system works, or the research area. The research area starts with the activity, what we do in our situation, normal scenarios. And for activity approach, how to identify the human activity, usually we use the smartwatches or smartphone, or the smart bracelet, the Fitbit, or IoT device. In this research, we focus on IMU-based sensor system for human activity recognition, and there are so many other approaches using vision-based approach. But the major challenge for vision-based approach is the security or privacy of a user, and there are some RFID-based and IMU-based system, and our research focus only on IMU-based human activity system. So here we can see we consider the IMU sensor, accelerometer, gyroscope sensors, and identify the user activity. In the area of application, the human activity research area focus on the human-computer interaction and the healthcare, IoT, or security of the system. And there are so many conventional approaches or the deep learning approaches, and I like to discuss more about the conventional human activity research area and deep learning research area. And we proposed a human activity recognition system to improve the accuracy of the system and identify the human activity in the real time. When we start with the human activity system, the conventional approach or currently existing research are support vector machines or CNN, conventional neural networks, and LSTM, long short-term memory neural network acts, and hybrid systems. So currently we focus on the hybrid systems. We proposed a CNN LSTM based neural network system to identify the human activity. So when we consider the challenges for human activity, the major challenge, most approaches require a domain knowledge and expert for feature engineering, and very high resource utilization, that the system for training and identify the human activity in real time. We need a high configuration system. Even for we had the challenge to train the data. We took more than 3 or 4 hours to train our system, and in real time, even due to some sensor problems, we had some delay problem. So we need a high accurate system to identify the human activity in real time. And the deep learning method, when we consider the deep learning method, the major challenge we face, like we did the activity data collection, Like I used the IMU sensor in my vest and I did the data collection for 3 activities: walking, standing, and sitting. Then what happened? We did the activity data collection more than 2 hours, and we have around 3,000 or 4,000 data samples. Then we trained our model, proposed model. Then what happened? The interesting thing, when the user changed, when we tried in real situation, we tried with another user, the performance was very bad. The accuracy is going down. So the major challenge for a deep learning system depends on the data, how much data we have, and if the data size is very high, the system gives better performance. So we have to consider that is one major challenge. And solution, currently there are so many researchers are proposing CNN networks or LSTM networks or the combined CNN LSTM networks to improve the performance of human activity recognition. And in this case, in this research, we proposed a hybrid network to identify the human activity in real time. So here the proposed method, we collected the data using the IMU sensor, we placed the IMU sensor in our vest, and the first stage of the proposed method is pre-processing. We divide the entire data based on a windowing based on 2.6 second. We divide the data, and we created our model. And we identified the activity. Together, the activity we also consider on the indoor positioning. So in this project, my research focus on indoor localization, and my colleagues they are working on human activity. Our final objective or goal of this research is to identify the user position, user behavior. Identify the user behavior, or considering the activity and localization together. I predict the user behavior based on this data. That is our final goal. And when we consider our CNN-LSTM architecture, the raw data, first we consider with the CNN layer, then LSTM layer, and we use the softmax layer to identify, to classify the activity based on laying, walking, or standing. And here, for comparison, we use two data sets from our lab. We created our own data set. In the PPT, we mentioned it ISPL data set. And for a universal data set, we consider UCI data set. So in the UCI data set, they have 6 activities: walking upstairs, walking downstairs, sitting, standing, laying. And in our data set, we didn't consider the compound activities. The current research, we focus on compound activities. Currently, we are doing data collection, and the system performance is not that much good. Around we reach around 68 or 70% accuracy, but we need to improve that. The reason the compound activity, when we do the compound activity, the sensor has some problem. The sensor movement is little difficult. So we need to consider how to solve that problem. And we compare the trained samples, some random sample and a test sample. And the sensors used in both cases accelerometer and gyroscope. In most of the human activity research, they use the gyroscope accelerometer data for identifying the human activity. But the recent research, they use the stress sensor. This sensor is also available. When attach the stress sensor in the human body, and they give a signal that based on that signal we can identify what type of activity is involved. And the device in the UCA dataset, they use the smartphone in west side. In our case, we purchased a with robot IMU sensor, and we place that the sensor in our wrist side. So when we consider the model configuration, the model consists of the CNN-LSTM, the hybrid network. The current research is everyone focusing on hybrid networks to improve the system performance, to reduce the error loss and increase the accuracy of the system. But still, the computation time is the major challenging when we consider as individual. If we consider only CNN model or only LSTM model, the computation time is less as compared to a hybrid network. And here, when we consider our accuracy, here is our first result based on walking, sitting, standing. And here we can see the model CNN-LSTM and CNN-LSTM dense model, LSTM dense model. So we compare with the three models. And the proposed model already achieved 99.06 accuracy. But the one problem here, we consider only very simple activities. So we can tell it's generalized a very good accurate system or something. But still for a basic activities, the system gives better performance. But our current research, we are focusing on compound activities, some complex activities. The person doing some gym activity or jogging or some jumping or falling down, or this type of compound activities. Currently, we are focusing on that. And next case is accuracy. You see a data set for both scenarios. And here we consider the loss for ISPL dataset, and here we can see as compared to UCL dataset, we have around 3.92. The loss will reduce as compared to the other dataset. In this dataset, we consider only 3 activities. The reason we collected only 3 activities: walking, standing, and sitting. So here we have a video demonstration. This is our recent result. So we combine our localization system and human activity system together. And here is our experiment area, the table and everything. First we created a floor map, and we identify the user position and activity together. But as the real fact is, it's a very simple activity system. But in our future work, we need to consider some compound or complex activities. But we have so many challenges. So currently we are trying to figure out how to solve these problems. So in this case, we identify standing position, and next also we consider the sitting position of the user. So in my conclusion, we proposed a hybrid model, CNN-LSTM model, to identify human activity recognition, and the proposed system achieved 99.09 accuracy with the basic activities. And we compared our system with the universal data set, UCI data set. And we also compared for architecture. We tried different architecture model, how the system performs for activity recognition system. And in the future work, hyperparameter tuning. So in this case, the learning rate or the optimizer, we use Adam optimizer, and learning rate, number of hidden layers, and the timestamps. These things are we need to do so many experiments. It's like a trial and error method to identify the best hyperparameter. So that we need to focus on that due to the time limitation. To run one model, to train a model, we need so much time. So to identify the hyperparameter is one challenging. We need to figure out the best hyperparameter for the model, and try to do complex activities, as I mentioned earlier. Like we need to consider some complex activities like riding bicycle or jogging or some other fall detection. So depends on the scenario. Based on that scenario, we need to create an experiment area, an experiment situation, and fix some activities and identify the human activity. And also we consider some available data set, compare with first we create our own data set and compare with the other data set. So thank you for your attention.
So thank you for your presentation. Yeah, time for questions.
I have a question. Your goal is recognize the human activity like the walking, sitting, standing.
Oh yes.
Based on some sensor information.
Yes, I use sensor.
Correct?
Yes, sir.
I wonder why you use the deep learning technique for that data set.
The significance of
Yeah. In this the like the TPS or the some gyroscope or accelerator.
Yes.
It may easily be detect some structures like walking or sitting or sitting.
Yes. I can explain it like when we consider the accelerometer, when we do the experiment continuously, the major challenge, major problem from accelerometer is accumulated error. So accumulated error is reduce our system performance. In the case of localization, identify the user position. When we do the experiment in the same area a couple of times, there is a drift. There is a drift from the sensor from gyroscope sensor. So to avoid these errors or to reduce the error, one significant way of solution is to introduce deep learning. So collect the data, train the model, and try with the test data. So the already model or system already know types of data. And the other thing, the noise affected the gyroscope or accelerometer. The gravity also affected the accelerometer. So to avoid or to reduce these problems, deep learning is one of the good approach.
I know. Deep learning is a very good approach, but have you ever tried compare with traditional machine learning or statistical approaches?
Yes, we did a comparison with the neural network, GNB, Gaussian base, and some other method we did, but the system gives accurate result for particular activities, not for all activities. So overall, the system performance is lower than as compared to deep learning approach. That's one. But the exact reason for that, why the deep learning approach give the best performance as compared to complex, like one thing is deep learning approach the feature extraction techniques as compared to conventional method. Feature extraction technique is better than as compared to normal conventional method. Or if CNN model or LSTM model, inside the model they have feature extraction techniques. But when we use the conventional method, we need to use data augmentation or the other feature extraction techniques. Like we use the discrete wavelet transform or short time Fourier transform techniques to extract the feature and to identify and to process the data. So when we directly use the CNN or LSTM, we can directly use the raw data. Then that system gives better performance as compared to conventional. Plus, if we introduce some data augmentation or data feature extraction technique before the deep learning network, again we can improve the system performance.
I understand. Like if you want to know the working, then we have to use the temporary information. That's why you use the LSTM. I understand. But basically, I wonder why you not compare with the other method you are
in this experiment. Okay.
I think because of the time, we can extend the discussion later. Any other questions? Yeah.
Alvin, thank you for your presentation. It's a good work that you are doing. I want just to come back to the sensors that you are using. As far as I understand that you are using two sensors, right?
For multi-user localization, we use for activity currently we use three sensors.
Okay.
But the major challenge for synchronizing both sensors is the main problem, and we have data loss. So
so you have two sources of data, or more than one?
Yeah, more than one, but not in this research.
Not this research.
Not in this research.
Because I'm wondering if we have more than one data sources, like 2 or 3 sensors that we collect data from. Do you think about how you can merge or you can fusion, so making data fusion in order to take the good decision? I mean, if your algorithm will take this in consideration or not? This is my question.
Yes, I think in the data collection we place one sensor here, and one sensor in our waist and one in my foot. So we did the data collection. We collected more than 1 hour data, but when we analyze the data, synchronizing between 3 sensors is the major challenge. We can't synchronize the data.
Okay.
That is a major challenge. And some sensors, they have data loss. So at a particular time,
So, excuse me, the data synchronization, you will do it before the correction or after the correction?
after collection,
After-
when we analyze the data, we have the problem. Data is not synchronizing with the 3 sensors. So that is the major challenge we face. But when we use only single sensor, we don't have any problem.
Of course,
Yeah,
of course, of
So
course.
that is the one problem for activity recognition.
Good.
Yes.
Good. My last question. So, so you are doing kind of localization in real time.
Yes, yes.
Okay. What about the AI? What about the deep learning? You are doing it in real time. Also, will collect data. You are doing your learning and then you take the decision, or
In this approach, we didn't use any deep learning.
Okay.
Deep learning approach. But still, the research for the locating the user position depends on our step length and our direction, which direction we moved. Based on that, only position estimation algorithm works. So we have research on deep learning approach for identifying the step length. So if one problem what I faced, that the same system we tried with a gender female, the system gave a totally different result. The reason female, they have different step length. So,
yeah.
that is the problem. Yeah. So this research we didn't use any deep learning for the localization.
For now, okay.
Thank you.
Thank you.
And,
Thank you, Alvin.
I think on schedule. First, I would like to check whether we have the third presenter here to present this side, the clinical decision support.
Yes.
Okay, that was all. So I will.